Hi everyone, this is your introductory lecture video on section 7.3, trigonometric equations. A trigonometric equation is an equation that has a trigonometric function in it. In these problems, for all the problems in this video, you are asked to solve each equation on the interval where theta is greater than or equal to 0 but less than 2 pi. So you'll notice here on number 14, I have a problem in black. It says 1 minus cosine of theta is equal to 1/2. So how are we going to solve this thing? I want you to look at the equation in the green directly to the right of our problem. If you had this problem in green, 1 minus x equals 1/2, you would be able to solve this thing. You would use your algebraic operations to isolate the variable x, and then you would be done with it. What we did for this problem in green is exactly what we're going to do for this problem in the black. When we tackle these problems, if we can, we want to isolate the trigonometric function. You'll notice that for number 14, that's exactly what I did. I subtracted both sides by 1. I got negative cosine of theta all by itself. I multiplied by a negative in order to get cosine of theta all by itself. So on this third line here, I have cosine of theta equals 1/2. From here, I will use trigonometry in order to solve for theta. This is going to give me two solutions here, theta equals pi over 3 and 5 pi over 3. Bear in mind, we are not looking for the general solutions for these problems. We are just asked to solve these equations for theta on the interval that theta is greater than or equal to 0, but less than 2 pi. Let's take a look at a number problem here. This is number 26. For the problem written down in the black, 4 cosine squared of theta minus 3 equals 0, I wrote an equation in the green. And for that equation in the green, if I asked you to solve for x, you'd be able to follow along with these steps. What we did for that problem in the green is exactly what we're going to do for this problem in the black. We want to isolate the trigonometric function. In that third line, you'll notice I have cosine squared of theta equals 3/4. From here, I took a square root on both sides. Because I took the square root of a variable, I'm going to end up with two answers. This is going to provide me with two equations here for cosine of theta. And I have written down their solutions right below the purple line. You'll notice that the starting steps of this problem, they're the same as the last one. You want to isolate the trigonometric function first. From there, try to use trigonometry to solve for theta. Let's take a look at this next problem, number 30. Tangent of 2 times theta is equal to -1. Now that looks strange, right? With all the other problems, it was just theta inside the trig function, but this is 2 times theta. You see this thing here that I underlined in the hot pink? I want you to treat that like one gigantic variable. You have tangent of a variable equals -1. The trig function is already isolated in this problem. Using trigonometry, the only times that tangent is equal to -1, if we just look for our variable being between 0 and 2 pi, this only happens at 3 pi over 4 and also 7 pi over 4. So this entire variable is equal to 3 pi over 4, and it is also equal to 7 pi over 4. We are not done with this problem. We were asked to solve these equations for theta. Dividing both sides by 2, I have that theta equals 3 pi over 8 and 7 pi over 8. So let's take a look at these first three problems really quickly. For quite a number of these problems, you want to isolate the trigonometric function first. And then what? Try to use trigonometry to solve for the input of the trig function. Sometimes the input of the trig function is just that variable theta. Sometimes it's not, but the directions that you follow are still the same. From there, once you've obtained your two equations or so, just solve for the variable theta. Now let's take a look at this next problem. The directions for this problem are still the same. This is number 65. We have sine squared of theta minus cosine squared of theta equals 1 plus cosine of theta. This problem is unlike all the other problems in this video. How are we going to solve this thing? When you have trigonometric equations that involve more than one trig function, you should try to rewrite everything in terms of one trig function. You see this sine squared of theta in our problem? My problem has a bunch of cosines in it. I'm going to take this thing here in the hot pink parentheses. I am going to rewrite this in terms of cosine. You can do this by using your Pythagorean identity for sine squared of theta plus cosine squared of theta equals 1. So I rewrote this on the next line. We have 1 minus cosine squared of theta minus cosine squared of theta equals 1 plus cosine of theta. Combining like terms on that left-hand side, you end up with the following. 1 minus 2 cosine squared of theta equals 1 plus cosine of theta. Now what do we do? Right now, we have a trigonometric equation that is rather quadratic. We are going to move everything over to one side. Ooh, let me erase this in the green here. In fact, I have to erase quite a lot of stuff here. When we move everything over to one side, we have negative 2 cosine squared of theta minus cosine of theta equals 0. Now what? We can't just get cosine all by itself in this equation with where we're at, right? Well, maybe we can. I'm going to write something down here in the green. So ignore this problem in the black for now. If I gave you a problem like this in the green, you would know how to solve for this thing, right? What would you do? You would either use the quadratic formula to solve for x, or you would factor. The way that you would tackle this problem in green is exactly what we're going to do to this problem in the black. So we're going to factor. You can factor out a negative cosine of theta from both of those terms. And now we have a product of two things set equal to 0. And so I'm going to set those two things equal to 0. Once I set these two things equal to 0, I will isolate the trig function. In the black, I have cosine of theta equals 0. That will happen when theta is pi over 2 and 3 pi over 2. In the purple, I have cosine of theta equals negative 1/2. The solution to this is when theta equals 2 pi over 3 or 4 pi over 3. Now, please bear in mind, for all of the problems in this video, you were only asked to find the solutions that were between 0 inclusive up to 2 pi exclusive. In Tuesday's lecture, we will be tackling problems like the ones shown here in this video. We will also take a look at problems in which they're not just unit circle values, right? Like cosine theta equals negative 1/2. That's a problem that you can solve using your unit circle. But what happens if you have a trig equation where it's something like cosine of theta equals 0.2, right? Like if you had something like this. I mean, how do you solve for this thing here? We're going to talk about how to solve these kinds of problems in Tuesday's lecture. Okay, that about wraps up this introductory video. I will see you in Tuesday's Zoom session.